In this video, we're going to talk about carbohydrates. We're going to briefly review monosaccharides, disaccharides, and polysaccharides. Let's start with monosaccharides. The word mono means one. So we're going to go over the simple sugar units. The first one is glucose. I'm going to draw that real quick. Glucose is a monosaccharide with 6 carbons. This is the cyclic form of glucose. It does have a linear form as well. And so this is how it looks like. This is the alpha form of glucose with the hydroxyl group down on carbon 1. This is carbon 1, 2, 3, 4, 5, 6. The chemical formula for glucose is C6H12O6. And it turns out that carbohydrates have the empirical formula C1H2O1. Thus, you can see the word carbon and hydrate. Thus, carbohydrates. Fructose forms a 5-membered ring in its cyclic form, but fructose have the same chemical formula as glucose. And the structure looks like this. Fructose is a ketohexose. In its linear structure, it forms a ketone functional group. Glucose is an aldohexose. In its straight chain structure, it forms an aldehyde functional group. Glucose and fructose are known as isomers of each other. They have the same chemical formula C6H12O6, but as you can see, they form different structures. Another one that you need to be familiar with is a monosaccharide called galactose. Glucose and galactose are very similar. They both form 6-membered rings and are both aldohexoses. Notice the key difference between the two. There's one small difference between glucose and galactose. Do you see what it is? Glucose and galactose, they differ at carbon 4. At carbon 4, the hydroxyl group is pointing up in galactose, but in glucose it's pointing down. Everything else is the same. Glucose and galactose are known as stereoisomers. They have the same chemical formula, their atoms are connected the same way, they have the same functional groups, but the only difference is that the way their hydroxyl groups are oriented in space. Stereoisomers have the same connectivity, but different spatial arrangements of the atoms. So glucose and galactose are stereoisomers. Now, galactose is specifically called a C4 epimer of glucose because it is at carbon 4 that they differ. And they only differ at one particular carbon, not 2 or more carbons, which makes it an epimer. Now, there are some other monosaccharides that you may want to be familiar with. The next one that I'm going to draw is a sugar called ribose. Ribose is a 5-carbon sugar, and it also forms a 5-membered ring. So that's the structure of ribose. Now, ribose is the sugar that is found in nucleic acids such as RNA. RNA stands for ribonucleic acid. Now, there is another 5-carbon sugar that you need to be familiar with. And the one I'm going to draw is called deoxyribose. Look at the difference between these two structures. What do you notice? Notice that the hydroxyl group has been replaced with a hydrogen. So that's why it's called deoxyribose, another 5-carbon sugar. Deoxyribose is found in a different nucleic acid called DNA, which stands for deoxyribonucleic acid. So those are some other 2 sugars that you want to be familiar with. And the simplest sugar is known as glyceraldehyde. This is a 3-carbon sugar. So that's it for the monosaccharides. So monosaccharides are basically 1 sugar units.